my talk, I deliberately changed it around. Usually, I'm a fairly technical guy, and I tend to go deep into the technology because I think that keynotes, which are too high level, are just fluff. We kind of sort of all know that. But then I have a 30-minute budget, which I'm going to start counting right now. Okay, 8:51. You guys keep me honest. And then, but I wanted to get some messages across. So I'm going to do that. I'm going to also move quite fast. So please excuse me for that, because I realize that I'm moving fast. I'll show you some videos as well. Okay, so having said that, here's sort of the agenda for the talk. I want to talk a little bit about these three things, okay? Edge computing, 5G, and some applications that are involved with all that stuff, and how they're changing the world, or in some sense. And I want to talk about a little bit of the history of how we came to this point, and then potentially where we are going with it. And in the process, hopefully you will start to see the opportunity, and it'll inspire you to work on these things. All right, so let me just put some things in context here. So Microsoft Azure is a pretty big bet for Microsoft. It's a massive, massive cloud, right? So here are some data, and this gets outdated faster than the talks that I have to give. So I had done this for a talk that was 6 months ago, and this data is probably obsolete, and we have become bigger because we are growing at a phenomenal rate, and we are building these data center sites, for example, that are way more than 160 at this point. But the interesting things that I want to point out here is the 2 million miles of fiber that we control, because I'm going to come back to that in a few minutes. And then if you look at the number of sort of the span the globe, and think about all the things that are connected to one another for us to run this cloud. So all the fiber we lease, all the interconnects we have, and all that kind of stuff. Okay, so we build data centers all over the world. These are some pictures of the data centers. And these data centers are built, there's a lot of, I wouldn't say tremendous science, but there's a lot of business acumen that is put into this to decide where to put these data centers. Each data center is built, it's a mega data centers, can have more than many, many hundreds of thousands of servers in it. And you have to think about cooling, you have to think about pricing, you have to think about networking, you have to think about all kinds of things when you decide where you want to put it. And so we have a team which goes and decides where to put it. And more countries, of course, want the data centers we put into their own regions for various reasons. We also have experimented with underwater data centers. I don't know how many of you have actually seen this, because there was a lot of news around this, even in the New York Times, which talked about Microsoft's underwater data centers. The point of that was that if you actually put a data center 25 miles away from the shore, then you're in international waters, and the rules are different. And the other point is that you're closer. The compute is closer to wherever you want to be. It's really expensive to build large mega data centers, but these ones, you build it, in 3 years, you replace it. So they're not built in a way that somebody actually goes inside of these things and checks everything. But it's built, and servers will fail sometimes, and things will happen, and then eventually you just kind of like move the whole thing out and put a new thing in. And so we've done the experiments, we've built it, we've shown the feasibility of it, and they are have worked out. The other thing I want to point out is that so to build, there are not going to be that many companies left in the world which do cloud computing, right? Because the amount of capital expenditure on building a cloud is massive, right? And the churn is massive. So every year we're spending lots and lots of money. We might be spending, over $1 billion, maybe a lot more than that, just over the networking part of it every year. So not every company can sustain it. And then, of course, the servers have to be replaced often, and you have to keep buying. So it's a very capital-intensive business. And so at the end of the day, when the dust settles, you will have a few companies left over with deep pockets which can actually sustain this business. But the interesting thing is that a pretty large number of companies have now taken dependency on at least Azure. So that's a good thing from our perspective. But also it keeps the business alive. Now, so when this was happening, I work in research. One of my jobs is to ensure that Microsoft has a future. And that's part of the job. The other job is really to extend the state of art. So I also have a researcher's hat on. and I publish prolifically, and my team publishes and we publish. And so we do believe in sharing knowledge. Anyway, so about 10 years ago, actually a little more than 10 years ago, I invited several people over to the Microsoft Redmond campus, and for a 2-day just discussion, brainstorming. And I said, let's just think what happens after the cloud. And so actually, this is a pretty picture. This is the offices that I work in. And out of this came this paper, which became the first paper to talk about edge computing. What we realized at that point was that, look, we are selling storage and we are selling CPU or processing, but we are not selling latency. Wouldn't it be cool to sell latency as well? But the problem with latency is that you have the internet in the middle, and the internet can't be sort of managed so well. Although things have started to change a little bit, and I'll explain to you what I mean by that. And so the idea was, well, if you can't get the computes fast enough, let's put the computes closer to it. So we call that cloudlets. Now, we were very focused on mobile devices at the time because IoT hadn't hit. It was just mobile devices. Actually, IoT had hit a long time ago, but people hadn't paid too much attention to it. But nevertheless, we were focused on mobile devices. And so this became the first paper which talked about how you offload computations to from a mobile device to an edge device. Okay, these are some numbers, but again, like I said, they are already dated because I haven't gone and things. And that was the first article written in 2009 about why a cloudlet always beats a cloud. So the genesis of this work began in Building 99 several years ago. And over the time, I had a little bit of hair at that time, but thank you for that. But that's what edge computing did to me anyway. So we were evangelizing, writing papers, publishing, and we were doing all kinds of stuff. But here's what happened. And a bunch of PhDs, a lot of students came and worked with us, and we served on the thing. So a bunch of PhDs, there are 2 more now that we did. Like I said, lots of papers were written. There was lots of media around it, but it didn't really catch on per se. We kind of knew we were onto something really big, but it wasn't catching on the way we would want it. Till IoT hit. Okay, so what was IoT? IoT was efficiencies. For example, if you have heard of Industry 4.0, it is about creating efficiency in the manufacturing process by infusing IT technology in there. All right. So how do you create efficiency? Well, they have things like robots. They have things that are sensors, actuators, all sort of stuff happen. And you cannot afford to take that data back to the cloud. You just don't have the time for that. So what you do is you put on-prem device, call it edge, and voila, you have edge computing and you have the efficiency. Now, of course, what we had done with the mobile stuff was very applicable to all of this stuff, because in the case of mobile too, or mobile devices too, or wearable devices, we were offloading computations that were too heavyweight for those devices, and so we had to use the edge for that. So anyway, so IoT hit, big deal happened. Microsoft pledged $5 billion investment into IoT and edge. This is when the current CTO, Kevin Scott, showed up. And he was from Silicon Valley, and he was starting to see this thing happen in the manufacturing, in retail, in health, in space exploration, all kinds of and Cisco was starting to push it in the car space, that sort of thing. And so he was able to convince the CEO, and they put $5 billion into it. And that really stepped up the whole thing momentum, and edge became a pretty significant thing. So what was the IoT angle to all this stuff? If you look at this picture, there was some animation, I removed it, but if you look at this picture, so you have sensors, right? You have sensors on your right side, and these sensors will now send the data to the cloud, okay? And the cloud will then, look at the data, analyze it, and send it back to the center or create an actuation. So initially, when IoT started, a lot of this stuff was again sent to the cloud, like I said. But then what they did is, as a first instance, they took whatever was happening in the cloud and pushed it down to the edge. What that meant is that for programmers, it wasn't actually any different, because whatever you were running in the cloud, you could run in the edge as well. And so the idea was that we would create all kinds of software which will just allow that to happen. So if you wrote an Azure app, it would just work on the edge. And we pushed it down there, and that was called Azure IoT. Okay, so there, I'll talk about one issue with edge computing later, but I'm going to say something here, which is that the strategy that was adopted was that you download a piece of software, which will be called Azure IoT Edge. You run it on your compute, and what it does is it actually creates an instance of the edge and then connects back to the cloud, allows you to write these things called Azure functions, or Amazon calls them lambdas, or in serverless computing now you have this service thing. So basically you write functions to process the data, but everything else is taken care of. So which means all the other data, all the other management of that stuff is taken care of in the cloud. So that was Azure IoT. So we would never actually send you any hardware. You just use your own hardware and you downloaded the software. That was the idea. Okay, so there are thousands, I don't know, tens of thousands of these devices out there. This is where the edge was running. So if you think of the edge, I like to show this picture because, in computing, we think about like, oh, the edge computing is all about some computing device sitting next to you or on-prem. It's like a server or something. No, it's not that. It's actually these kind of things. So these kind of instrument. And you can see the kind of companies that build this are very different from the IT companies. But now they put processors in it and put Linux, for example, on it or something. And then they could download this Azure IoT thing, and they were connected to the cloud, and voila, you can now manage. So this is a picture which sort of shows that you can manage thousands of these devices sitting in the center, in the cloud, and just doing whatever. And so as you got this framework in there, you were able to do more and more sophisticated work. Like if things went bad, you kind of like knew it went bad. You could sort of try to figure out how to self-manage these things and things of that nature. So that's kind of like the edge. But that wasn't enough. A lot of people wanted managed edge because they sort of said, hey, when you brought in the cloud, you basically told me I don't have to get my IT guys. I don't have to hire any IT person because you're going to manage it all for me. You're going to manage the hardware for me. You're going to manage everything for me. And now suddenly you're asking me to manage all this stuff. So I want a managed edge, or I want something. So then Microsoft produced this thing called Azure Stack Edge, which was a server class machine. And this is sort of like a robust, much more robust packing of it. And this had an FPGA. Now it has a GPU. It has a beefy processor. It has a lot of storage. And the idea is that you can take this device, put it on-prem, and it'll do whatever you want it to do. And then it'll also get managed from the cloud. And then if you had disconnected operation, which is one of the big scenario for edge computing, is that if you're sort of in a mining place, or if you're doing oil rig or something, then sometimes the networks go away. Then what happens at that point? This device will continue to work. It has a tremendous amount of storage, so you can keep working. And when the network comes back, it'll send it back. So this is a sort of a picture here. Let me see if I can parse this for you. So you've got a bunch of sensors here. There's the DataBox Edge, or Azure Stack Edge that I mentioned. It has a FPGA somewhere here. There's a GPU, for example. There's local storage. And so it runs, in the processor, it runs this Azure IoT software that I talked about, which then connects back into the Azure cloud. And then it just sort of sustains itself, and it works very well. And this is selling very well, and lots of people are using it. So one example of selling very well are these companies. There are a lot more. I can mention these companies directly because they're using it, and there are scenarios. So for example, in the Shell case, they are looking at it for safety case, where they have cameras and things looking at spills or what have you, and dwell times of like cars that come in. In the Alaskan case, they have these micro weather patterns, and so they have lots and lots of roads, and they get icy, and when they get icy, people, cars crash, they can die. So what they do is they actually drive these trucks around, which are measuring temperatures various places. The edge is computing and predicting whether there will be a bad weather storm or not, and sending it back, and then they are routing whatever little fleet they have into that place to de-ice and put salt and things of that nature. And there's the order I mentioned, which is sort of disconnected. So there are many, many, many companies, and these are actually interesting scenarios if you sort of look. They have some of them on the website, and they have videos of explaining all this stuff. That's kind of cool too. Now, what happened is, so this is fine. Microsoft is doing all this stuff. What was I doing in the process? So we did the edge stuff quite a bit, but I was looking for a killer app, in a sense, an app that would justify edge. Now imagine. This is happening in parallel to what we were doing. So we were moving along. So what we noticed that there were cameras everywhere, right? If you go to New York City or any city, LA, San Francisco, you will see cameras are everywhere. And then you have to ask the questions, who's looking at that? And the answer is nobody, really. What is happening is that they're being stored, and if something bad happens, then people will go back and look at the camera and try to analyze. So the question in my head was, can I actually do analytics in real time and raise alerts when something bad happens, so that we can reaction times are faster, and maybe even we can predict something bad is going to happen and prevent that from happening. So that was sort of the big thing. And for that, I kind of just knew that I can't take the video back to the cloud. It's just going to take too much time, too much bandwidth. It's too expensive. What if I put these servers or edge devices close to that and do it? Okay, so as I was doing all this work, I also found out about this program called Vision Zero. Does anybody know what Vision Zero is? That's all right. I didn't know it either when I started. But so Vision Zero is a program that started in 1997 in Sweden, and the idea was that before I tell you this, I have to tell you this. Traffic fatalities are the 9th leading cause of death in the world. And this is over malaria, which, for example, Bill Gates has been focused on malaria and all at about 12. So it's a pretty serious thing, and people die all the time. So in 1997, Sweden had started this program called Vision Zero, and the idea was we've got to get this number to 0. We have to prevent traffic fatality. Because if you think about traffic fatality, it's human error or machine or whatever. We should be able to do that. This picture that I'm showing, so once I found out about Vision Zero, I found that there were many, many cities around the world who had actually had programs like Vision Zero. And so they were not, but the progress had been slow. So anyway, I wrote this paper along with that, which is that can we use video analytics towards Vision Zero? All right. So I'm going to show you a little bit of a video, and pardon me, I'm in the video myself, but it's faster to show it as to what we did with the city of Bellevue, which is a neighboring city of where, in fact, I live in the city of Bellevue, but neighboring to Microsoft, and this is what we did. Sorry. The city of Bellevue was working towards this program called Vision Zero. The goal of that program was to get to a point where there was 0 traffic-related fatalities. The way they would do it is they would manually send people to intersections and count how many things were happening. Now, this is not a scalable solution. It requires a lot of money. It requires a lot of time.
Microsoft reached out to us and inquired about leveraging our existing camera system to derive insights on how people move around our city and to address a major safety concern, road collisions.
Traffic-related deaths are among the top 10 reasons for fatalities worldwide. So we thought this was a project that has a great technical potential and a huge social impact. It takes each of the frames of the video and it detects all the objects that are present. It sees what the direction of these cars is and increases the appropriate counts for these various directions.
What's really exciting about the partnership that we're developing with Microsoft is the opportunity to leverage cloud computing, machine learning, and other technologies.
Video analytics has created an opportunity to be able to do something that can potentially save lives, and people are willing to deploy everywhere. I can see this being used with smart cars or self-driving cars. We have opened up people's eyes of the possibilities. That's what we are after. Okay, so the video, so this is the pilot we did. It actually worked very well. But what it didn't tell you was how do we save lives, right? So what happens is that we build a platform, and over that we start to sort of build heuristics or algorithms, which sort of looked at which intersections were more dangerous than the others. And so that was part one of that. And so once we knew which intersections were dangerous, then the city could actually spend more money on those particular intersections with either changing the traffic light pattern or broadening the streets or doing whatever. So that was one. The other one was to work with smart cars. So here's an example that we demonstrated in 2016 in Hannover Messe. So if you don't know do you know what Hannover Messe is? Okay. Some people. Hannover Messe is one of the biggest manufacturing retail show in Europe. more than 100,000 people showed up, 6,000 companies show up, and what they are focused on is they are focused on, as I said, manufacturing and creating efficiencies of manufacturing. So car manufacturers show up too. So we sort of show this technology. I'm going to show this it's not as spiffy a video like the one I showed you before, but you can sort of see that you have a camera sitting on top of the light, and it's watching everything. And so even if a smart car or a self-driving car shows up, can't see this person which is between the two cars, but the camera sees it, right? If the camera sees it, it then is able to sort of either direct the traffic lights or send warnings. So I don't know if you can see it, but if you see this dashboard, you see a human being, sort of a sign for a human being, right? This lights up. So this was a car which actually had that dashboard. This lights up, and either the smart car will slow down, or the self-driving car will slow down, or the traffic signal will have the slowdown. So this is one way that you can reduce it. This is, as I said, just a sort of a small example. Another example that we showed in 2019, and this is again a very crappy video because it was done internally, showed internally at a thing called Tech Fest that we have routinely, where we sort of show how pedestrians can be helped. So this has video and audio, I think.
Here we show how a Microsoft Edge computing device can save lives by analyzing a camera feed in real time. When a person in a wheelchair is detected on the crosswalk, the device resets the pedestrian lights timer, allowing the person in the wheelchair to safely cross the street.
So you may have noticed that that number changed, right? As the camera looked at the person and said, this person is not going to be able to cross in time, it changed that number of how long the light stays alive. So I'm just giving you some flavor of how real-time analytics of video data can help it. Now I leave it to your imagination. I'll say one more thing, and then for example, why did we focus on intersection? Because of these numbers. There's a lot of stuff, bad thing happening on the intersections. And if you think about just from a pure money perspective, and if you want to have a startup or do some business on this, you can start to see that you have a lot of intersection. And I have some numbers that I'm missing the slide on here, not showing it to you, but I have numbers which show like the existing tech for all this stuff is really, really expensive. So one of the things that one can do is drive the cost down by innovation and by doing something smart. And here's the sort of the table that I set, where you can sort of see this is road traffic accidents, and this is malaria somewhere here. Yeah. So I mean, the reason I sort of show that is because you see a lot of focus by, for example, Bill Gates on this. Okay. So one of the things that came out of the Bellevue trial was that they had a roadway system. Actually, I live on 108. And they wanted to put a bicycle lane in it, but they didn't know whether it'll disrupt traffic or not disrupt traffic. Will it be good for the city or not? And there was no scalable way to do it. But what they did is then they put our system in there, which did the analytics over a few months or whatever, and then gave them the numbers and basically said, go ahead, build a bicycle lane and you'll be fine. They build a bicycle lane, and then again they use a system to see how that had an impact, and they found that it had very little impact on the cars, but a tremendous impact on the bicyclists. So you can start to see how these technologies work. Now, the Bellevue system, got a lot of had national coverage. This is a letter that you probably can't read, of course, but from Washington D.C., Mayor of Washington D.C., which talked about how video analytics is so important for this sort of thing. You see all these partners in there. There were some awards that were given. This is the guy from the city of Bellevue getting a national award for deploying a system like that. The Department of Transportation also gave them an award. So it was all good. Now, what I was saying earlier was that I leave it to your imagination to say that this is one scenario where cameras are being used with edge computing, with analytics, machine learning, AI, to improve lifestyles or improve lifespans, let's say, reduce. But you can think about other scenarios in manufacturing. I mentioned that multiple times now, retail businesses, or your favorite other industry that you like. and see how you can security, world security, that sort of thing, how you can apply the same kind of tech to this industry, to that particular industry. Now, I'm going to go, I am technical, so I can't actually just not do anything technical, so give me two slides I'm going to do. I wanted to have you appreciate what it means to build something like that, okay? So if I think about video analytics and a video pipeline, I think of it as transforms. And I take a bunch of transforms and I put them in a sequence, okay? So in this particular case, I have this camera, the camera taking the imagery. Then I have the first transform, which may be just decompression or decoding or whatever. Okay, following that, I want to do some background subtraction. Following that, I want to do some object tracking for that, and then I put them all together. Okay, and then that makes my video analytic pipeline. The interesting thing is that if you kind of like go and look at how research is moving, they focus on each of these things separately. Right? You've seen coding, decoding algorithms to compression. You've seen sort of like object detection algorithms. And then, so for example, when we look, there were to the order of 40 object detection algorithms that people thought were great. And there were 60 tracking algorithms that people thought was great. So which one to use, right? So that was the sort of the problem. I didn't actually go into this thing trying to say, I'm going to be a vision researcher. I'm a systems person. I wanted to build it all, but I didn't know what to do. So this is difficult to parse, so just bear with me, for example. So this, the rightmost thing is about object detection, object tracking, and classifying it. What these dots are showing is that there are so many different parameters that I can tune to get a certain result. In all cases, most cases, I think, the vertical axis is accuracy, and the horizontal axis turns out to be how much CPU you're using with a particular algorithm. Now, I mentioned earlier that cost is important. So you do want to use less number of CPUs. So for example, if you take this particular graph here, right? If you think about this accuracy, you could have picked this, and you would have used to use this much CPU. But you could have also picked that and use 100 times the amount of CPU. And the difference between the two is very minimal. So how do you know going up front what is what, which one to use, what parameter to use? The problem becomes expounded because what happens is that some of these algorithms work well in certain cases. So when the lighting conditions are great, something will work great. When the lighting conditions are bad, it starts to rain, there's something bad happen, the other one will work. So then you have to sort of say, I got to figure out a thing that can actually match a curve. And then you have to sort of think like, okay, what are the trigger mechanisms for that, right? And then on top of all that is that because you have all these different things, when you put them all together, that's yet another complications. Which one works better with this? Which one works better with that? That sort of thing. So now you can see the combination of all this stuff is a tremendously hard problem. And when I said, people have written PhDs and all of that, that's part of the reason where they're trying to solve the problem. It's not a solved problem yet. There's still problems when you have to think very deeply about it. So at the moment, what you do is you try to do the best you can with what you have. And you try to use heuristics, you try to sort of come up with things. But who's to say that the heuristics that we use were the right ones and that somebody else can't come up with it? So for the students who are here, you have to think about this as like, this is an open platform. We haven't really opened, and we haven't really nailed it down yet. I mean, it works. We've sort of shown that there are scenarios it works, but it's not really nailed down. Okay, the other thing I want to say, which is semi-technical here, is that the way you should think about this is that you've got data coming in, and then you want to solve that problem on the edge first. But edge is also not as resource strong as the cloud is, right? So what you do is you try to use some cheap or simple CNNs, for example, right? If you're sort of into CNNs, convolution neural networks, you try to solve it that way. And if you think that you've solved it, then voila, you're good. But if you can't solve it, then you want to send it to the cloud, which is now going to use a much more heavyweight DNN or CNN, whatever, right? So to be able to solve the accuracy problem. So then what we ended up doing was building a system that automatically knows how to do that. So we had to come and think about really hard about what does it mean for the accuracy to be good and whether to keep it in the cloud, keep it on the edge or keep it going in the cloud. So that is yet another pretty serious technical problem. And that problem actually hits you because you're working in real world, right? If you were in academia and you just wanted to build something great and show a number that looks great, you wouldn't have to worry about it. The reason we worry about this sort of thing is because we know that people are not able to pay the kinds of money that you need to for them to pay for all kinds of GPUs and CPUs. So we have to build a system which people will take. Okay, so here where I want to show you another angle to something which is about privacy. People always ask me, you're doing all this video analytics, what do you do about privacy? Okay, I'm running out of time here. So, so this is a video of an intersection. So what we do is we've actually built a system which will only give you a query for the things that you want to query for. So in this case, you wanted car query, so the only thing you see is cars. Okay, and the way sort of you to think about this is that you got stuff coming in here, and then for whatever query that you're allowed to see, that query the system will produce video for that, and then put a key to it, right? Encrypt it and put a key to it, and give you the key. So then you can only see that and not the others. So that way you kind of sort of maintain the privacy. And this is an important point because privacy will always come up in video analytics. And so who is allowed to see what is what we're trying to address here. We built a big stack. I don't have time now to go because I have to wrap up. We built a big stack here. And then what we did is, I apologize again, I'm going fast. Like I said, this is a longer talk, but I just want to give you a flavor of what is happening. And we made it open source. So the point is that, which is that you can actually download all the, you're going to download all this stuff, run it yourself, and start building applications, or even putting new modules into it, or doing research with it, or doing whatever, right? So this is all available. You obviously have to spend time to learn some of this stuff. This talk is not about that. This talk is about introducing you to this thing. So this is, you can go to GitHub, download the thing. Let us know. We'd love to help you out too, because we are actually kind of excited about ensuring that everybody is able to use it. And the stack is called Rocket, so that's an easy name to remember. There was all these articles written about it. This was called last year was called the Year of the Edge Computing, etc. This is a big deal. Now, I want to leave you with one thought, and then I'll wrap up. The thought is the following. So if you I started working on edge computing and started edge computing back in 2009, as I showed you. And so a lot of years have passed, and I've had time to think about it, reflect, see how the world has moved, what we need to do. And I have now think of all the stuff that I described to you as classic edge. So, which means you put computes near the user so that they can do it. But the future is about even bigger. It's about using the edge as part of the infrastructure. And this is happening all over. Once I've told you about it, and if you're interested and you start to search and think about it, you will be surprised at how much is happening there. So my job here is to just make you aware of it. I looked at all the papers that are being published here, and I didn't see any papers on these sort of topics, and that's why I think it's important for you to sort of do that. So what I'm saying here is that there's a telco industry which moves packets, correct? Which moves packet from one end to the other. And then there's the IT industry which does the same thing, correct? And so these two industries are separate. They're doing the same thing. So this is now going to be a $500 billion transition, and where you've got the telecom networks, and then you've got the cloud networks, they're going to converge, okay? And this is the last picture. This is saying that if you think about how the telco network works, this is the cell base station, this is the RAN, which is the radio access network, this is the central offices where they run this mobile core, they call it 5GC or whatever. This is the network, this is the internet, and then back down. Now, if you think about what an IT company does, it manages cloud, it manages, as I said, more than 100,000 miles of fiber, as I've already told you, and I showed you the scale of it. This is now the trend is to do all the stuff from hardware in software. This is where edge computing sits, right? The RAN is that element, which is the base station, which now people are starting to build. It's really hard. So what this is doing is this is radically changing how the telco industry has done work in the past. And because of this radical shift, you've got a thing happening where the telcos and the IT industry is coming together, just like I said they were coming together in manufacturing and retail and healthcare, et cetera. And this transition is going to impact everybody, because now everything that you do with your communication is going to go through the edge. And now you can bring all the computing stuff that you talked about on the edge for the edge network onto this as well, which then allows you to build applications of the kind that you've never ever seen happen or built in real time. You can have tremendous graphics here in your devices. You can have games running. You can do telemedicine. You can do all sorts of really, really fun things. And so that, I think, is kind of important. That's why I'm saying the telco and the IT industry are sort of like, this is a thing that will help them both. And yeah, that's it. That's all I wanted to say. And the 30 minutes, a little bit higher, I guess.
Victor Bahl.
Thank you. Yeah, I went 5 minutes over. Sorry about that.
Okay.
Okay.
People are paying attention, taking a lot of pictures, so I
Okay.
think it's fine. Normally, I check your hand. Can
Oh,
I tap
no,
your
you can
feet?
do namaste. I don't do namaste. Namaste is a
Namaste?
great.
Yeah, of course.
Sure.
Namaste.
Why not?
Of course, you can ask him questions about anything you'd like to know about the Edge, about projects he's been working on.
Yeah.
But first, I saw people taking a lot of pictures. Can we share the slides?
Yeah, I can. I'll send you the slides. Sure.
Yeah, then, and we'll send them to you all.
Yeah.
Yeah.
Yeah, sure. Happy to do that.
See a lot of happy faces, so
Yeah, you
thank
can.
you so much.
There is, I had to condense this material quite a bit. So if you feel that you learned something interesting or new that you hadn't thought about, then yeah, you'll give you the slides. But go and check it out. And even we have a web page on a project called Edge Computing where we put a lot of stuff in there. So papers we've written on it and other talks I've given.
Give us the link.
So you're welcome to
We'll
look at
provide
that.
that as well.
And yeah, it'll be. I think that a lot of us need to get engaged in this thing. I think we have to step in and help out and expedite it because there's a lot of goodness in where we're trying to go.
Awesome. Thank you so much. Are there any questions about edge computing, about the projects? Yeah, of course. Please tell me your name, where are you from?
Hi, my name is Ankit. I'm from Northern Virginia, so East Coast. So my question was related to your, you're talking about the wheelchair that's crossing through the crosswalk. Later on in your presentation, towards the end, you also talked about how, in this research, you need to use algorithms that can adjust for brightness, that can adjust for rain, that can adjust for a bunch of different conditions. Considering the fact that these traffic weather lights, they are outside, and there are plenty of different weather conditions, what specific types of algorithms that are you using in conjunction with your convolutional neural networks in order to sort of increase accuracy, and how have you found success with those?
This is a deeper question than I can answer very quickly.
What's the essence? What's the most important thing you would like to know that he can answer in a short amount of time?
It's a pretty deeply technical question.
Yeah. Why don't we? If it's a very technical question,
Yeah.
we can take this offline and talk about that.
Oh,
Because
that's fine, yeah.
if I won't be able to do justice to the answer if I give you will not be satisfied, and I will not be able to tell you.
Well, we have
So,
a
but
half
I'm
hour
happy to
break
talk to
coming
you.
up.
I'm around here. I could
Okay.
definitely talk to you and tell you exactly what we're doing, precisely what we're doing.
Yeah.
So thank you for asking.
Awesome.
I actually want to, before you ask this question, I was thrilled to see that there are a couple of high school students here. Is that right? Yeah, I was like, wow, that is, my God, what are we going to do? Middle school next time or elementary school? That's great, though. Good to have you guys here. Yeah.
Okay. Any other question, perhaps? Yes. Who are you? Where are you from?
Hi, I'm Ugo from Nigeria. So just generally speaking, how do you say edge computing is going to impact the telecommunications industry?
Sure, that I can explain. So over the years, we have gone, if you think about the history of cellular, right? Every 10 years, they produce a new G, 3G, 4G, 5G, whatever, right? So you ask the question, well, if you think about the IT industry, I mean, the speed with which the IT industry moves is far greater than the speed for the telco industry. And so you have to ask the question, why is that the case? When you think about it harder, you start to realize, well, one of the reasons is the capital cost. The ability for the telcos to move from one G to another requires them to spend billions of dollars before in the infrastructure space before they can move, right? So, but the problem with all that is that innovation is happening very fast. We are able to, we are producing and being smart about doing things much, much faster than the 10-year thing. So you have to combine the two. Now, so this has been very frustrating for the telecom industry because one, they get, I'll give you an example of 5G. So there's tremendous pressure on them to move to 5G. What is 5G? 5G is high bandwidth, low latency, ubiquity. These three things, right? High bandwidth, low latency, ubiquity. What does high bandwidth means? It means more than gigabits per second. What does low latency means? 1 to 4 milliseconds on a thing. Ubiquity means that no matter where you go, you have the same level of service. Now, technically, we know how to do this. We have known how to do this for a long time. Like if you heard about massive MIMO, we know how to do that, but they can't put it in practice. So the way you put it in practice is you remove the dependence from hardware solutions, which is what they are. So there are companies that sell, I won't name the companies because some of you might be here, but there are companies that sell all this hardware gear for them, which is the radio hardware and the RAN hardware and the even the core hardware. And so, but the telcos, but the IT industry has done a pretty good job when they evolved themselves to cloud to remove the dependence from hardware and put a lot of that in software. Because software you can move faster on, right? And you can churn faster on. And so that is what is happening. The IT industry says, hey, we have already done this transition to the cloud. We understand the pain you guys are feeling. We know how to do software. And we're going to turn all the hardware stuff into software, including the radio RF processing stuff. And that'll lower your capital cost by significant amount. People say 50%, 60%, whatever. And it'll give you the ability to move faster on the features. And it'll have you the ability to create more revenue for you because now you can put different kinds of APIs on top of your software that you can allow the developers to use to write applications. So it creates a new revenue stream, it reduces the capital cost, and it makes you move faster and makes you future-proof. So all this stuff, makes sense. And so now the question is, how do we get to that point? So people are in agreement. So that's what I mean when I said that there will be a convergence of IT and telco. IT industry has been doing this for a long time. And also there's been sort of this other thing that has happened when the telecoms grew up, they grew up with their own stack. They pretty much did everything that the IP stack was doing. But they grew up separately. So there used to be meeting I used to go to where they used to do these two stacks doing the same thing. But the telecom guys were very, very scared to touch anything in the stack because they believed in this 5.9 availability. Your phone is always available to you. But they realized because this is a problem for them, they couldn't get many developers to learn or do innovation on them, that they started to converge. So now a lot of the stuff that telco does is on the IP stack, and IT companies know the IP stack really well. So there's a lot of reasoning here why it makes sense from a money perspective, from a, like I said, future perspective. Does that make sense?
Feels inevitable. It will happen. The question is when.
Yeah, the question is now, actually. It's inevitable. Somebody was pointed out that people, like for example, I talked to I forget the name, the CEO of the Deutsche Telekom, and he was saying that he's very frustrated that the telecoms are just a pipe. And then companies like Facebook, Microsoft, Amazon are making billions, even though they are the ones connecting them. Yeah. But they also knew that to be able to make more revenue, they have to innovate. And their speed of innovation was not as fast. They were operators, right? They wanted to turn from operators to development. So I think that's kind of like underlying all this. So that was many, many years ago, and so this has been taken a while. But I think now all the ducks are lining up, and that's why I said, if you have time, just type in 5G, type in RAN, the word RAN, type in IT, telco. You will see so many hits, and then you will say, oh my God, where have I been? I mean, I even this morning when I came, I heard some big news that you guys can hear about.
Thanks so much for the elaborate answer.
Sure.
One more time, Victor, Bahl.
Thank you.